Canada's commitment to achieving net zero emissions by 2050 requires a multifaceted approach, leveraging key technologies and strategies. This presentation examines four critical pillars of Canada's path to net zero: energy efficiency, electrification, energy storage, and carbon capture innovation. By improving energy efficiency across sectors, electrifying transportation and industry, developing advanced energy storage solutions, and pioneering carbon capture technologies, Canada can significantly reduce its greenhouse gas emissions while maintaining economic growth. This presentation explores current initiatives, future potential, and challenges in each area, concluding with policy recommendations to accelerate Canada's transition to a low-carbon economy. Canada, like many nations, faces the urgent challenge of transitioning to a net zero economy by 2050 to combat climate change. The path to net zero emissions in Canada is multifaceted, involving technological innovation, policy reform, and investments across various sectors. This presentation focuses on four key strategies that are critical to Canada's decarbonization efforts: enhancing energy efficiency, accelerating electrification, advancing energy storage technologies, and innovating in carbon capture and storage. These interconnected approaches offer the potential to reduce greenhouse gas emissions while fostering economic growth and maintaining Canada's position as a global energy leader. By examining current initiatives, future potential, and challenges in each area, this presentation aims to provide a roadmap for policymakers, industry leaders, and stakeholders to navigate Canada's transition to a low-carbon future. Energy efficiency is a cornerstone of Canada's strategy to achieve net zero emissions, offering a cost-effective approach to reducing greenhouse gas emissions while enhancing economic competitiveness. The importance of energy efficiency in the net zero transition cannot be overstated, as it addresses the fundamental challenge of doing more with less energy input. Initiatives in Canada include energy-efficient retrofit assistance for homeowners and numerous commercial and building assistance programs. These programs are continuously evolving. The future potential for energy efficiency is vast, with opportunities in industrial processes, transportation, and smart city technologies. However, challenges persist. The upfront costs of efficiency upgrades can be prohibitive for many consumers and businesses. Additionally, the split incentive problem in rental properties, where landlords bear the cost of upgrades while tenants reap the benefits of lower energy bills, hinders progress in the residential sector. Solutions to these challenges include innovative financing mechanisms, which allow property owners to finance energy efficiency improvements through property tax assessments. Enhanced building codes, mandatory energy audits, and increased public awareness campaigns can also drive adoption of energy-efficient technologies and practices across all sectors of the Canadian economy. Electrification plays a pivotal role in Canada's decarbonization strategy, offering a pathway to reduce emissions across multiple sectors. By shifting energy consumption from fossil fuels to electricity generated from low-carbon sources, Canada can leverage its renewable resources to power a cleaner economy. Key sectors for electrification include transportation, buildings, and industry. In transportation, the federal government has set ambitious targets for electric vehicle (EV) adoption, aiming for 100% of new light-duty vehicle sales to be zero-emission by 2035. The building sector is seeing a push towards electric heat pumps and induction cooking, while industrial processes are exploring electrification options for heat and power needs. However, the widespread electrification of the Canadian economy requires infrastructure investments. The electricity grid must be expanded and modernized to handle increased demand and integrate higher levels of variable renewable energy sources. This includes upgrading transmission and distribution systems, implementing smart grid technologies, and developing more robust interprovincial connections to optimize clean electricity sharing across regions. Challenges include the high upfront costs of electrification in some sectors, particularly heavy industry, and ensuring a reliable electricity supply in remote communities. Policy support, such as incentives for EV purchases and industrial electrification projects, along with strategic infrastructure planning, will be crucial in overcoming these barriers and accelerating Canada's electrification journey. Energy storage is a critical component in Canada's transition to a net zero economy, playing a vital role in integrating renewable energy sources and ensuring grid stability. As the share of variable renewables like wind and solar increases in Canada's energy mix, storage technologies become essential for balancing supply and demand, improving grid resilience, and enabling the efficient use of clean energy. Current storage technologies in Canada include pumped hydro storage, battery systems, and emerging technologies like compressed air energy storage. Innovations in battery technology, particularly in lithium-ion and flow batteries, are driving down costs and improving performance. Canada's abundant mineral resources position the country favorably in the global battery supply chain. Scaling up storage capacity presents both opportunities and challenges. Challenges include high capital costs, regulatory barriers, and the need for further technological advancements to improve efficiency and durability. To accelerate the deployment of energy storage, Canada is investing in research and development, demonstrating large-scale projects, and updating regulatory frameworks to recognize the value of storage services. Carbon capture, utilization, and storage (CCUS) technologies are important for Canada's net zero goals, particularly in addressing emissions from hard-to-abate sectors such as heavy industry and fossil fuel production. These innovations offer the potential to reduce greenhouse gas emissions while allowing for the continued operation of key economic sectors. Canada is working at CCUS development, with several large-scale projects already in operation. The Quest project in Alberta, for instance, has captured and stored over 5 million tons of CO2 since 2015. Future potential lies in expanding CCUS applications to sectors like cement production, steel manufacturing, and power generation. However, CUS faces technological and economic challenges. The high cost of capture technologies remains a barrier to widespread adoption. Additionally, the development of CO2 transportation infrastructure and identification of suitable geological storage sites are crucial for CCUS deployment across Canada. To address these challenges, the Canadian government has implemented supportive policies, including the CCUS investment tax credit and funding through the Strategic Innovation Fund. Research is ongoing to improve capture efficiency, reduce energy requirements, and develop novel utilization pathways for captured CO2, such as in building materials or synthetic fuels. As CCUS technologies mature and costs decline, their role in Canada's emissions reduction strategy is expected to grow, complementing other decarbonization efforts across the economy. To accelerate Canada's path to net zero, the following policy recommendations are proposed. 1. Implement a national energy efficiency strategy with increased funding for retrofit programs and stricter building codes. 2. Expand electric vehicle incentives and charging infrastructure investments to accelerate transportation electrification. 3. Develop a comprehensive energy storage strategy, including regulatory reforms to value storage services and increased R&D funding. 4. Enhance support for CCUS through expanded tax credits and public-private partnerships for infrastructure development. 5. Establish a green innovation fund to support cross-sector collaboration and commercialization of clean technologies. In conclusion, Canada's path to net zero emissions by 2050 requires a coordinated approach leveraging energy efficiency, electrification, energy storage, and carbon capture innovation. By implementing robust policies and fostering technological advancements in these key areas, Canada can successfully transition to a low-carbon economy while maintaining its position as a global energy leader. The SGIN Energy Leadership Series delivers accessible understandings concerning our continuing need to drive clean energy implementation and at scale. In this series, our industry network of leaders share insights and understandings as to the major issues we face and break down the myths and noise that can be barriers to achieving clean, beneficial energy for our subsequent generations. This presentation is brought to you by the Smart Grid Innovation Network. We foster Canada's transition to clean energy, helping build stronger, more resilient communities and a sustainable economy. To learn more about us, please visit us at sgin.ca. Thanks for watching.